10, the diagram shows a pentagon, ABCDE. Find the area of the pentagon. So I've got this pentagon, but I can see if I split it up, I could make it into a compound shape. I've got a rectangle here, and if I put my head on my right shoulder, I can see this is a trapezium. So I'm going to redraw this one out. That length is 42.5, that length is 34, and the base is 54. So we're going to need to find the height of this trapezium later, but let's first get some marks and find the area of this rectangle. Areas of rectangles, you just multiply the base by the height, so 48 times by 54 is 2592. Let's think about how we would work out the area of this trapezium. So the formula that we need for area of a trapezium is a plus b, so I add up the two parallel sides, I divide that by 2, and I multiply that by the perpendicular height. So I need the height that's going straight up. A and b are 34, add 54, divided by 2, and I need to find this height. So how can we do that? I can see I've got a right angled triangle that's formed just here. So I'm going to draw that over here, and we'll try and find the height. So the diagonal, the hypotenuse, is 42.5. The base of that right angled triangle will be 54, take away 34, so that base will be 20. I'm trying to find one of the shorter sides, so I'm going to do the square root of 42.5 squared, taking away 20 squared, and square root all of that, and that will give me my height. So 42.5 squared, take away 400, which is 20 squared, and that leaves me with 37.5. Now that I know that height of that trapezium, I can substitute it into the formula for area of a trapezium and find that value. So 34 add 54, 50, 80, 88. 88 divided by 2 is 44. So I'm doing 44 times by 37.5, which is 1650. All I need to do now is add both of these together. 1650 add 2592, which gives me 4242. And the units for that would be in centimetre squared.